let's write a signature to describe the stacks that we implemented before. We'll start with list stack. So I've created my signature for stacks now by specifying all the values, their names, their types, and their behaviors with these documentation comments. Now I can tell OCaml that I want to check that list stacks do have that signature. And indeed, they do. Now what about my stacks, though, which we implemented up here above before? I'm going to grab that code and put it below. Could I say that my stack has type list stack sig? I get a compilation error when I do that. The values do not match. Empty is not included in empty. And notice the two types there. Alpha stack is not included in alpha list. What's going on here is that my stack signature required empty to have type alpha list. And inside of list stack, that is exactly how it's implemented. But of course, inside of my stack, I'm not actually using the list type to implement my stacks. I'm using something very similar, but it's not exactly the same thing. And so empty does not have type alpha list here. In fact, it has type alpha stack, which is defined up here. So the signature that I wrote for stacks was not general enough to describe related stack implementations. It only described that particular implementation with lists. Let's generalize the signature. Now I have a signature for stacks that doesn't mention lists anywhere. It just mentions that there's a type alpha stack that is used to represent stacks. List stack does meet that signature because it provides a type alpha stack. And my stack also meets that signature because it provides its own type alpha stack. Let's also create a signature for queues. So it took me a while there to develop that specification as I was going along. I had to work out what I wanted to do with options and write down the behavior of each of those functions. Now that I have my queue signature, I could move this code all the way up above the definitions in the file of toListQ and listQ and specify that listQ and toListQ need to have that module type. But let me show you one other way of doing this. I can also below here say module listQ has type Q and is equal to listQ. Now that's a little confusing because I'm rebinding a name that has already been bound before. I'm shadowing. So in order to get rid of that confusion, let me go back up here and just change this name up here. This is the implementation of listQ, let's say. And down here, I can say that's the implementation of listQ. So this is our first example of the right-hand side of a module definition not being a structure, but just another module value. So listQ_impl is a module value that was defined up above in the file, and I can bind it to the name listQ, and at the same time I'm binding it, I can also specify a module type. Of course, I wouldn't have to do that. I could leave that off. Now I could do the same thing for my two list queues. Now OCaml is satisfied that both of those modules have the correct module type.